In this lesson, we're going to talk about the difference quotient. So one of the basic definitions in calculus uses this ratio f of x plus h minus f of x, and the whole thing's divided by h. It's called the difference quotient, so it has a really important application to calculus. While we're not in a calculus class yet, we do know how to apply some of these function operations. So we're going to just begin with f of x plus h. So we have a function f of x is 5x minus 6, and we want to figure out what would f of x plus h be. So this means we're replacing the input with x plus h. So for our function, we would have 5 instead of x, we're replacing it with x plus h. And we simplify what we can. So f of x plus h would be equivalent to 5x plus 5h minus 6. There are no like terms that we could combine. The second step would be to determine f of x plus h minus f of x. So if we were to do that, I'm just going to rewrite this again down here. So I got some room. That would mean we have f of x plus h, which was 5x plus 5h minus 6. And we are subtracting f of x, which was 5x minus 6. Remember, when we're subtracting more than one thing, we want to be clear that that whole thing is being subtracted. So put that in parentheses. That would simplify to 5x plus 5h minus 6 minus 5x plus 6, because you're subtracting a negative 6. As I look at what simplifies, 5x minus 5x is 0. Negative 6 plus 6 is 0. So all that's left in this f of x plus h minus f of x is 5h. The last part of the difference quotient takes that difference, f of x plus h minus f of x, and divides by h. So in this case, f of x plus h minus f of x, the whole thing divided by h, would have left us with 5h over h. We can simplify that to just 5. So the difference quotient would be 5. I broke that part, or that difference quotient, up into 3 parts to kind of help organize that information a little bit. But typically you would see a question written like this: determine the difference quotient of this particular function. Sometimes this takes a lot of paper, and depending upon how big you write, you may end up using a whole page. But the important thing is to keep your work organized. So for this one, I'm going to start with just determining g of x plus h. For this quadratic function, you have more than one x, so each of those is going to be replaced. This would leave us with 5 something squared minus 3 times something plus 1. Each time we see an x, it's being replaced with x plus h. And we need to simplify this expression. So if I'm doing negative 5 times this squared, exponents come before that multiplication. I cannot distribute that 5. I have to do exponents first. So what I'm going to do is just rewrite that x plus h twice, because that is what being squared means. And then we'll simplify that a little bit more, because I can distribute out that x plus h times x plus h. That would end up being x squared plus 2xh plus h squared. Now if you need to remind yourself off to the side how that happened, you can do that. X plus h times x plus 8, we are distributing. And by combining like terms, we're going to end up with this expression, x squared plus 2xh plus h squared. At this point, now we can do our multiplication, because we have already squared x plus h. So if I distribute, that's negative 5x squared, negative 10xh, negative 5h squared, we can distribute the -3. But looking across this whole g of x plus h, there's nothing else that can combine. I can't simplify that any further. So let's actually do the difference quotient. I'm going to abbreviate it just dq, but the difference quotient states you have g of x plus h minus g of x, and the whole thing is being divided by h. I find g of x plus h separately most times to kind of make my work a little bit more organized. So in this first spot, I know I have g of x plus h. Then I'm subtracting g of x, which was -5x squared minus 3x plus 1. I use these brackets, or you could use parentheses, but whatever, to group and just show this whole thing was g of x plus h. I'm subtracting all of g of x, and then we'll start doing our simplification. There's nothing to distribute in that first set of parentheses, but I do need to distribute the subtraction. By subtracting a -5x squared, it becomes plus 5x squared. We get plus 3x and minus 1. The whole thing is being divided by h. But if we simplify the numerator, -5x squared plus 5x squared is 0. -3x plus 3x is 0. And +1 minus 1 is 0. What's left in the numerator is -10xh minus 5h squared minus 3h. Hopefully what you'll notice is that every single one of those terms in the numerator has an h, so there is a GCF of h in the numerator. I could factor that out. That would leave me with -10x minus 5h minus 3 over h. The reason I factor out that GCF is because to reduce a fraction, you would need a common factor. So we could reduce a fraction like 14/16 by a factor of 2, because there's a common factor of 2, which makes that 7/8. So in this case, we're reducing out that h. We are left with only -10x minus 5h minus 3. That is our difference quotient. And for now, that doesn't mean a whole lot to us because we're not in a calculus class, but it does give us some algebraic operations to practice. On the back of that page, or the next page, you'll see this relationship between the average rate of change and the difference quotient. The difference quotient is an application of the average rate of change. The average rate of change is the slope between two specific points, and if we were to find the difference, or the average rate of change of a point x and f of x, this is going to be our point x, the output would be f of x. And then we have this other point that's a certain distance away from x. So we're going to say that's x plus h, x plus some distance h. And this output would be f of x plus h. So by applying the average rate of change, which is our slope formula, we are doing f of x plus h minus f of x all over our x plus h minus x. That simplifies out to the difference quotient. So it's a generic average rate of change between 2 points. In calculus, we'll get to use that to talk about the instantaneous rate of change. All right, in this example, we just want you to try to find the difference quotient of f of x. So if you want to pause the video, use what we did in the previous example, and then you can press play and check your work. All right, so I would start out with f of x plus h. we have 3x plus h squared plus 4x plus h. Because we have something squared, we need to write it twice. So 3 times x plus h plus 4 times x plus h. We're going to distribute my x plus h so that we can get that value squared. I get x squared plus 2xh plus h squared. And now I can distribute to finish that out. That's 3x squared plus 6xh plus 3h squared. And then distributing the 4, I get plus 4x plus 4h. None of those terms simplify, but we can find the actual difference quotient, which is f of x plus h minus f of x all over h. So if I put in what we just found, 3x squared plus 6xh plus 3h squared plus 4x and plus 4h, we are subtracting f of x, which was only 3x squared plus 4x. By simplifying that numerator, I get 3x squared plus 6xh plus 3h squared plus 4x plus 4h. There's that f of x plus h. We're subtracting the 3x squared and subtracting the 4x, which will let me simplify the numerator. We are left with 6xh plus 3h squared plus 4h on top. It's all divided by h. If we take a factor of h out, that's h times 6x plus 3h plus 4 all over h. We reduce the fraction. Our difference quotient is 6x plus 3h plus 4. There's one more for you to try, and it is a linear example. Now, linear ones are actually easier than quadratic ones, but this one has a fraction, and sometimes the fractions scare people off. If we brave through it, we do g of x plus h first. So we're replacing that x with x plus h, which leaves me with 4/5 x plus 4/5 h minus 11. So our difference quotient would be g of x plus h minus g of x all over h. If I put in the g of x plus h, that's 4/5 x plus 4/5 h minus 11. G of x was 4/5 x minus 11. And we simplify that numerator. That would leave me with 4/5 x plus 4/5 h minus 4/5 x plus 11. So simplifying 11 and negative 11 is 0. Negative 4/5 x and positive 4/5 x is 0. We are left with only 4/5 h divided by h. By simplifying that fraction that has a common factor of h, this is only 4/5. So what looked a lot scarier is actually less work because we're not having to deal with something squared. Now, as you get to calculus, you will apply this application. We talk about decreasing that distance. This is going to be labeled as delta x, but we had talked about that being h, a certain distance away from x. So as we decrease the distance between the 2 points, all right, you can obtain the slope of the tangent line. Tangent is where it touches only 1 point. And as the 2 points on this secant line get closer, that average rate of change approaches the instantaneous rate of change. So we're looking at what is that average slope between the 2 points to what is the instant slope at that between the 1 point. So the instantaneous we go. The instantaneous rate of change is the slope of that tangent line. So the difference quotient is going to help us in calculus eventually find the slope of a tangent line. All right, so if you need more practice with these difference quotient ones, there are some in the lab manual to look at. Specifically focus on these linear and quadratic ones for right now. You can find the difference quotient of any function, whether it be a rational function or a radical function, but the algebra takes a little bit more work.